In this video, we're going to look at an example that has a couple different sub-scenarios. Maria earns $60,000 per year and saves 5% of her salary each month in a retirement account that earns 6.5% per year compounded monthly. The company that Maria works for also contributes 3% of her salary. If she works at this job, continuing with these contributions and never earning a raise, a little unlikely, but it gives us an estimate. How much would she have in her account after 25 years, round to the nearest cent? So we're first going to do this using the formula, and I've written down some of my easier to identify values. We know it's 25 years, so our T is 25. We know it's compounded monthly, so our M is 12. We know that it's 6.5% compounded monthly, so that's my R. It can be a little confusing to look at this and see, okay, there's a 5% there, there's a 6.5% there, and there's a 3% there. Which one of those is my R? Notice that the 6.5% is attached to how the interest is compounded, so that's my interest rate. We need to figure out how much she's putting into the account each month. So that's the first thing that we're going to do. Her annual salary is $60,000. She's not contributing all $60,000 because then she wouldn't have anything to live on. She's contributing 5% of that each month, and her employer is contributing 3%. So a total of 8% is how much is being contributed. Now, this would be the annual amount that she's contributing. So in order to get the monthly amount, we would have to divide by 12. So the amount of the payment is going to be the 60,000 times 0.8 divided by 12. This turns out to be $4,800 divided by 12, or $400. The last thing I need to do is identify what our goal is. So our question is, how much will she have in her account after 25 years? So my goal is the future value. And this is the reason I've chosen the version of the formula that is solved for future value. If I input all my values into this formula, it's going to look like this. When I go to enter it into my calculator, I need to make sure to put parentheses around the numerator and then a second set of parentheses around the denominator. We will end up with $299,534.61 in Maria's retirement account. If we were doing this problem using the TVM solver, our N would be 12 times 25, our I would be 6.5, our present value, this is the amount that we start with, and so in that account, when she first starts saving, she should have $0. Our payment, this is the amount she's depositing each month, this is going to be negative 400, and again, you can make this positive, but your final answer will be negative. Our future value is our goal, and payment per year and compounding per year are both going to be 12. So you're going to enter these values into the TVM solver values, stick the cursor on that future value, and press alpha enter to get it to solve. We should get the same exact answer as we did the first time we did this. Our future value is $299,534.61. In this next question, we're trying to find out how much interest Maria would have earned over the 25 years. Remember, we can think of our future value as the part that comes from the deposits that we make or our payments, and the rest of it is going to be interest earned. So our future value is the total payments plus that interest earned, and so we can solve for interest. That interest is going to be the difference between our future value and the total of our payments. Our future value was the $299,000 number here. We had 12 payments per year, 25 years, $400 payments, so this is the total payments, and so we end up with over $179,000 in interest. After 5 years, Maria gets a new job. In the 5 years at the first company, she had managed to save up a little over $28,000. In her new job, she got a bump in salary, and so her salary is now $80,000, And because of this bump in salary, she plans to step up her savings. So she plans to contribute 10% of her salary each month, and the new company is going to contribute 3%. So there's going to be a total of 13% each month that gets contributed. If the new retirement account also earns 6.5% compounded monthly, how much will she have in the account after 20 years? So in order to do this, we need to think of the two types of monies separately. So this $28,000, this is the amount that she saved in the old account, and that amount is going to stay there and it's going to keep growing interest, but we aren't going to be adding onto it. For the $28,000, we just need to use regular compound interest. This ends up growing to a little over $100,000. $103,366.25 to be exact. For the remainder of her savings, this second calculation is going to be based on the 20 years of additional deposits. We need to figure out how much each deposit is, though, before we move on. She's earning $80,000 a year. She's contributing 13%, so our new payment is going to be $80,000 times 13% divided by 12. So she's going to be contributing $866.67. That's going to be our new payment. Now, some of the numbers in the TVM solver are going to be the same and some are different. Because we're only looking at for another 20 years, our N is going to be 20 times 12 instead of 25 times 12. Our I is the same. Our present value is the same. We have a new payment and we're looking for our future value. The future value is $528,399.36, and the original goal was to figure out how much does she have total, and so we need to add these two numbers. We need to add the future value of the $28,000 plus the future value of all of our new deposits, and we end up with $528,309.36. That's it for this video. Thanks for watching.